Hello guys, welcome back to the next lecture on the PY question series. Today I will explain you one of the most important lecture on the GATE as well as the IIT JAM mathematics exam, and that lecture is eigenvalue problem. Myself Dr. Harish, you can simply follow my YouTube channel where you can find the playlist and see the GATE mathematics playlist is available. You can see the various PY questions on the different topics. You can see with the help of the shortcut tricks. There is one more playlist named as the IIT JAM solution, and again you can see the PY questions related to the statistics as well as the mathematics for you. Now always remember firstly, before I start with this one, always remember, whenever you will see any matrix in your examination paper, then you can solve that problem with the help of eigenvalue problem, whether they are ask you about the eigenvalue or not. But remember, whenever the matrix is given to you, whether it's a linear transformation, whether it's a function analysis, any of the things, always try to solve firstly by eigenvalue. Fine. Now what is that given to you? A has the eigenvalue 1, -1 and 3. Then your target is to prove for the non-singular. So what is the definition of the non-singular? So if I say matrix A is a non-singular, when the determinant should be non-zero. Fine. Always remember, the only two tips I will give you, and based on that I can solve each problem. So if you find the determinant of any matrix which is equal to the product of eigenvalue, and if you want to find the trace of the matrix, that should be the sum of the eigenvalue. So based on these two shortcut tricks, I can solve each question available in this lecture as well as any of the things. Now firstly, a square plus a. What is the eigenvalue of the a square? So I can put a square of this 1, -1 square is a +1, 3 is my 9. So what is the eigenvalue of the a square plus a? I can add them. It's a 2, it's a 0 and it's a 12. So for the non-singular, what is the determinant of a square plus a? So clearly say it's a 0. But for a non-singular, we need a non-zero. So this option is cancelled. What is the eigenvalue of the a square minus a? This is a square, this is a. If I subtract them, it's a 0. This is my 2, this is my 6. Again, you can see a square minus a is my 0. So this option is also cancelled out. A square plus 3a. So what is the eigenvalue of the a square plus 3a? I can multiply this by 3 and add them. So 4. It's a minus of 2. If I multiply by 3, it's a 9 and 18. So clearly say what is the determinant of this, which is non-zero. So yes, it's a non-singular. Look at the last option, a square minus 3a. If I multiply by 3 and subtract them, it's a minus of 2. If I multiply by 3 and subtract them, it's a 4. This is a 0. So because of this 0, product of the eigenvalue is a 0. So it means this option is cancelled. C is my right answer of the problem. Okay, A is my 3 cross 3 matrix. Again, matrix is given, so you need a 3 eigenvalues. With the trace is my 3, determinant is my 2. One of the eigenvalues is given as a 1. Fine, one eigenvalue is given to you. So we know if I say 3 eigenvalue, trace is my 3. So what is the eigenvalues of the other 2? Because the trace of the eigenvalue is the sum of the eigenvalues. So the trace is my 3, so it means the remaining 2 eigenvalues as here. Product of determinant is my 2, so the product of these 2 eigenvalues is also my 2 because it's a 1. So once you know these 2 equations, I can solve by say m square minus 2m plus 2 is equal to 0. So what are the eigenvalues of this? I can solve it's a plus minus b square minus 4ac divided by 2. So 1 plus minus iota. Fine. So what are the meaning of this? Eigenvalues are 1 plus iota and 1 minus. Now you know all these eigenvalues. So what is the eigenvalue of the a square? A square is a 1. What is the a square of this? It's a 2 iota, and a square of this is my minus 2 iota. Then what is the eigenvalue of the a square minus 2i? What is the eigenvalue of that 2i? Is a 2, 2 and 2 because it's a 3 cross 3. So I can subtract minus of 2 is a -1. So firstly is a minus 1. So plus 1 cancel. I subtract them. This minus 2 iota minus 2. So minus 2 iota minus 2, 2 iota minus 2, 2 iota minus 2, but it's a plus sign. So the right option is D is my correct answer. A is a matrix, the sum and the product of the eigenvalue. The sum of the eigenvalue is my 10, product of the eigenvalue is my 30. So this is my 3 cross 3. So you have the 3 eigenvalue. The trace, this is my trace. So that means A plus B plus C, it should be 10. And what is the determinant? So you can see it's a lower triangular matrix. So 3AB is my determinant of this. It is 30. So from here you can see A plus B is my 7 and AB is my 10. So clearly say the values are my 5 and 2. 5 and 2 7 and 5 and 2 10. So the two eigenvalues are my 5 and 2. And since the sum of the eigenvalue is my 10, so what is the we need a and B only. Fine. So what is the value of the A square plus B square? But if you want to find the third eigenvalue, the sum of the it is not a eigenvalue. This is the, yes, A, B and 3 are the eigenvalues. So 5, 2 and 3 are the eigenvalue. So what is the A square? 25 plus 4, 29 is my is the right answer. And what is the eigenvalue of this? Since it is a diagonal matrix, so A, B and C 3 are my eigenvalue. That means 5, 2 and 3 are my eigenvalues. Okay, A, B, C are the distinct non-zero eigenvalues. Distinct non-zero eigenvalues with this condition. So for what value of the A, B, C? You can choose any value of the A, B, C and D which satisfied this property. So A plus B should be C plus D. I can choose, they are distinct and non-zero. Now what is that? It's a 0. So I can choose C and D such a way they are distinct and here. Fine. So I can substitute this value here. What is the A? A is my 1, B is my minus 1, C is my 1, D minus 1, 1 minus 1, 0. Then which of the following is here? What is the A plus C? This comes to be my 3. This A minus B is come to be my 2. A plus B is come to be 0. And B minus D is come to be 1. Fine. So now then the eigenvalue of this. Can you find the eigenvalue of this? So firstly you can check about the determinant. So determinant will be 0 plus 1. It is my 0 minus 1 and plus 1 of minus 2 plus 2. So clearly say 1 minus 1 0. Fine. So it means it has a 3 eigenvalue. One of the eigenvalues is my 0 and he said one of the eigenvalues. So clearly say 0 satisfied. So B is my right answer of this problem. Okay, then you have to find the eigenvalues of the B, eigenvalues of the A. Okay, so always remember, whenever you have the matrix A which is of the A, B, C and D, you can find the eigenvalues directly by using here trace of the matrix plus determinant of A is 0. So if I write for this, what is the trace? Minus iota. Fine. What is the determinant? 0 and it will be 1 minus iota and 1 plus iota. So it will be 2. Fine. So can you find the eigenvalues of this? It is minus B plus minus B square minus 4AC over 2. So it will be the 3 iota plus minus 3 iota over 2. So that will be my 2 iota and it will be my minus iota. Fine. So it has a 2 cross 2. So what is the eigenvalues of the A? A has the eigenvalue 2 iota and minus 2 iota. Now look at the option. Eigenvalue of the A is my 0. That's the wrong option. A has a non-zero real eigenvalue, but both are my imaginary eigenvalue. Now we all know the eigenvalues of the A and A transpose are same. So it is also same. What is the eigenvalue of the A complex conjugate? So it's a minus of 2 iota plus iota. Then we need a product of this. So what is the eigenvalue of the product? You can multiply them. It is my minus 4 iota square minus iota square. That means 4 and 1. 4 and 1 are the eigenvalues of the B, and eigenvalue of the B are purely imaginary. Wrong option. Eigenvalue of the B are real. That is my correct answer. Okay, P and Q are the two matrix of size 4 cross 6 and rank of this. Okay, always remember, rank of the AB should be less than of the minimum of rank of A and rank of B. This is one first property. Second property is rank of AB should be greater than or equal to rank of A plus rank of B minus n. Now what is that n? N is the column values of this first matrix. Column values of this A, whatever the first value of this. Now look at that, rank of this. So I can apply the first definition. 2 must be less than of minimum of rank of Q 4, rank of P is not given, so let's say x, fine. And this second property, it should be greater than of rank of Q, rank of P minus n, column vector of the P, Q, column vector of Q is my 4. So what does it means? 2 is greater than equal to x, means x is less than equal to 2. Now from here, the minimum of 4 and x, so definitely x should be greater than equal to 2 because the minimum is my 2. So from these two results, what you got? X is 2. X is my rank of this is my 2 is the correct answer. Okay, the largest eigenvalue of the matrix. Fine. The largest eigenvalue. So it is a 3 cross 3. So it has a 3 eigenvalues. So what is the sum of the eigenvalues? Can you find these values? So that means it is nothing but the trace of the matrix. Fine. So the trace will be my 21. Now what is this matrix? If you clearly say this matrix is my symmetric matrix. Fine. So what is the, we all knows whenever you have a real symmetric matrix, so it is a real as well as the symmetric matrix, what kind of the eigenvalues you have? Eigenvalues are always greater than or equal to 0. So what does it mean? If you have the 3 eigenvalues, none of the eigenvalue is my negative. So what can you say about that? What is the largest eigenvalue? Can you find the largest eigenvalue? Largest eigenvalue itself 21. Fine. So the largest, because sum of the eigenvalue is 21, so this option and this option cancel out. So if it is one of them is a 16, other must be, sum of them will be 5, but the largest eigenvalue will be 21 if 2 eigenvalues are 0, and it will be here. Okay, look at this another one. M is given to be here. B is a non-zero matrix, so that mx is equal to b. Then your target is to find this. Firstly, I can write this value. It means I have to pre-multiply by x transpose on the both side. Fine. So my target is to find this value. So it means equivalently I can found this value. X is in my here. So it means I can return this is my x, y, z. M is my 0, 1, minus 2, 0, 2 minus alpha 0. What is the alpha? Alpha can be any number. So I can choose alpha is 1 because alpha is any number. Fine. No, I can't take the alpha because if alpha is 1, they both are the same number. So I can choose alpha is my 2 so that all the options are different. So I can substitute here is alpha is my 2. Fine. You can choose any alpha other than 0. If I choose alpha is 1, then you can see these two options are same. So I have to use the distinct numbers. Then it will be x, y, z. Fine. So now I can multiply them. Firstly, I can multiply by here. It will be y minus 2z. It is my minus x plus 2z. And it will be my 2x minus 2y. It is x, y, z. So what is that? It's a xy minus 2xz minus xy plus 2yz plus 2xz minus 2yz. So this value will be cancelled, 2xz cancel, so this value will be 0. So 0 is the right answer. So that could be easy if you choose the particular value of the alpha. Fine. Otherwise, if you don't want to choose any alpha, you can write as alpha and alpha. But that may sometime it will be the confusion. So you can choose the value of alpha as per your own choice, so that the options are my uniques. Okay, look at again the matrix is given to you. Your target is to find the trace of the M. What is the trace is? Alpha plus beta plus gamma. This is your target. What is given to you? Mx is equal to 0 has infinitely many solution. When it has infinitely many solution? When determinant of M should be 0. Fine. Or you can say the rank of the M is not equal to the number of the column vector. So what does it mean? The determinant of M should be 0. So if I take the determinant of M, it is minus 1, gamma minus 1, plus of 1, 1 minus beta should be 0. So if I open this bracket, it is alpha beta gamma, it comes to be 1. So 1 minus alpha minus gamma plus 1 minus beta is 0. So what is that? I can find the value of alpha plus beta plus gamma. So can you find the value of this? 1 plus 1, 2 plus 1, 3 is the right answer of this problem. That's a very simple target. Here the concept of the infinitely many solutions. Okay, alpha, beta, gamma are the eigenvalues of this, and how you can find that. Okay, always remember, okay, if any, if not, I can write here, okay, if each row or column, any one of them has same sum, fine, then same sum, say is equal to k, for example, then k is the eigenvalue. Fine. For example, if you say the sum is a 0, sum is a 0, is a minus 1, it's a 2, it's a 3, it's not the same. If you look for the column wise, it's a 1, it's a 1, it's a 1, it's a 1. Now you can see the sum is my same. So it means it's a 4 cross 4. So one eigenvalue is my 1. Clear? The first. Now because it's a 4 cross 4, clearly say the one of the row is my 0. It means if I consider this is my M, determinant of M is 0. So once the determinant is a 0, and we know the product of the eigenvalue is the determinant, so it means at least one eigenvalue will be 0. Fine. Now how you can find the remaining two eigenvalues? Any idea? I think that's again a very, very simple. How you can think about that? How you can okay, if there is no need to write here, remember a minus lambda is 0, there is no need to write like this. Fine. If you closely look about this matrix, do you get what is that? Look at that. What is the diagonal entries? Below the diagonal entry is a 1, above the diagonal entry has some matrix. So this matrix is called as companion matrix. Fine. Remember always when the matrix is said to be the companion matrix, if you look about the diagonal entries, either whatever the diagonal, either the above values all are my 1 or the below entries are 1, either one of them. So here it is a below 1. So you can write the characteristics equation directly. It's a 4 cross 4. So I can written as lambda raised to power 4 minus, start from this below 1, minus 2 lambda cube minus 1 lambda square minus plus 2 lambda minus 0 is, this is the correct. Otherwise if you write like a minus lambda is a 0, again you will get the same equation, but there is no need of that. So now you can see lambda cube I can take from here common, minus lambda square I can taken as a common. So from here one eigenvalue is my 2. Fine. Now we got a 3 eigenvalues. The fourth eigenvalue I can obtain from the trace. So you can see what is the trace of this matrix is 3. So definitely the one other eigenvalue is minus 1. Otherwise you can find this from here as well. Fine. So from here clearly say lambda square is common. So this will be, yeah. So no, something is error. Lambda will be common. So it is my here. So it is lambda is common, lambda square. So it's a plus minus 1. Now all are eigenvalues. If alpha, beta and gamma delta, what is the value of this? 1 plus 0 plus 4 plus 1, 6 is the right answer. Remember, this is a matrix, a very special form, is a companion matrix. Anyhow, we already obtained the 2 eigenvalues in a very simple manner. Rest of the eigenvalue you can obtain. Okay, look at this one. Again you can see, okay, firstly I can find the eigenvalues of the m. How I can obtain? Minus trace of the m plus determinant. So what is that? What is the trace of this? Half. Okay, but I think there is no need of this, because you can see it's a lower triangular, so eigenvalues are directly here. Fine. Otherwise you can find from this also. So what you got is lambda is my half and 1. These are the eigenvalues of m. I need m raised to power n. So what is the eigenvalues of this? Half raised to power n and 1 raised to power n. So therefore what is this matrix? This value will be half raised to power n, 1 raised to power n is here. Lower value is 0 and I need to compute this value. Fine. Now I have to multiply by x also. If I multiply by x is my 3, 4. Then if I take n approaches infinity, you can see this number is my 0, 0, 0, 1. I need to calculate this value into 3, 4. So if I multiply them, what will happen? The first value will be this into 4 and this second value will be 4. So the second column will be 4. So this value will be cancelled. Does not exist is a cancel out. Fine. Now how you can find this value? So that I can again tell you. It's a very simple. If you look about this matrix, okay, I write this matrix if I call this is A, this is A square, 1 and 0. Fine. So what is the m square? So A square 1 0, A square 1 0. Remember we need only this value. Fine. That is A12. So what is the A12? First row, second column. So it's a cube plus A square. Fine. The first value is my A square. Second value is A cube A square. What is the next value? So you can see A square A cube A4. Fine. A square A cube. Then similarly what is the M4? A square A cube A4 A5 and so on. So what is the Mn? It is A square A cube and up to A of n plus 1, because it's a 3 is a 4. So what is that? It's a GP. So GP is my 1 minus A raised to power n divided by 1 minus A. What is the A? A is my half. So once you take A half and n approaches infinity, this value will be my 0. So this value will be my 1 over 4. 1 minus half is half. So it will be my 1 over 2. Now you can multiply them. You will see the answer will be 2 and 4 is the right answer of this problem. Okay. M is my n cross n matrix such that m cube is equal to I. Firstly, think about whether this is a characteristics polynomial, whether this is a annihilating polynomial, or this is a minimal polynomial. Look at that. What is the size is? N cross n. But this is not the n. It means it is not a characteristics polynomial. Minimal polynomial, it is not given. So that means this, if I called here is lambda cube minus 1 is 0. This is basically my annihilating polynomials. Fine. And we all know whatever the minimal polynomial, it always divides annihilating polynomials. So what are the factors of this? This minus plus 1. Fine. So what is the minimal polynomial of the matrix M of A? It could be either lambda minus 1, or it could be lambda square plus lambda plus 1, or it could be lambda cube minus 1. Fine. If this is the minimal polynomial, what is the eigenvalue? 1. If this is the minimal polynomial, now you can see it's a minus b, 1 minus 4 over 2. So minus 1 root 3 iota over 2. And you can see this is omega square. Omega is the cube root of the unity. And from here it is 1 omega square. Now you can see about the second line. What does it means? mv is not equal to v. What does it means? 1 is not the eigenvalue, because we all know ax is equal to lambda x, then this is my eigenvalue, but he said not equal to, so it means this option is cancelled. And look at the last option, this also cancelled. The only degree of this my here, this one. So what is the degree is? 2. So it means n is divisible by 2, it is not divisible by 3. Now what is the eigenvalue of the m? Is a omega and omega square, both are the purely imaginary parts. M has the real eigenvalue, cancel out. Now m has the eigenvalue omega square. What is the eigenvalue of the m inverse? 1 over omega square. Then, and we all know what is the 1 over omega? Basically it's omega square, and 1 over omega, this is my here. So if you add them, m plus m inverse, omega plus omega square, and omega square plus omega. You know what is the value? We all know 1 plus omega square is 0. So this value will be my minus 1, this value will be my minus 1, and both are my real eigenvalues. So the right answers are B and C are the correct answers. Okay, look at this another one. This is the 4 cross 4 matrix. The roots means eigenvalues are my here. So this is my plus minus, so I can written as a lambda square. Okay, if this is my lambda, so what is my plus minus of this? Root 5 over 2. Then my target is to find the m raised to power 8. That means my target is to find the lambda raised to power 8. So I can return this number like here. Fine. I can scaling them. 4 lambda raised to power 4. What is the scaling of this? 5 plus 1 6 plus minus 2 root 5. Or I can divide it by 2. It will be 3 plus minus 2 plus minus root 5. Then again I can scale them. So it's my 4 lambda raised to power 8. It's a 9 plus 1 14 plus minus 6 root 5. Again I can divide it by 2. So it will be 7 plus minus 3 root 5. So what is that? This is the m raised to power 8. Now look at that. I need a m square. What is the m square is? Here. Fine. So clearly say how I can become a 3 root 5 when I can multiply this by 3. So only one option is my here. Or otherwise you can substitute here. What is my m square? 1 plus minus root 5 over 2. So clearly say if you take the LCM, it is my 4 7 plus minus root 5. Plus minus 3 root 5. You can see this is the same number we have obtained as a m cube. So rest options are cancelled. Okay, look at this another one. Again it's a 4 cross 4 matrix. So it has the 4 eigenvalues. One of the root is my here, and you have to find this value. Very simple. You can see this is my one root, and we all know complex number occur always in the pair. So the second root will be here. We also know the irrational number always occurs in the pair. Fine. So if the root 2 plus iota is there, then minus root 2 plus iota is also the root, and from here minus root 2 minus iota is the root. So these are my 4 eigenvalues. Fine. Now it's a very simple, you can pick any one of them and substitute in these options. Look at that. If I take first option, say this value, fine, then I can find this value, so I can scale them. So it will be 2 minus 1 plus 2 root 2 iota. So that means lambda square minus 1 is 2 root 2 iota, and I need a power 4, so again I can scale them. Plus 1 minus of 2, it will be my minus 8. So what is that? Lambda 4 minus 2 lambda square plus 9 is my 0. So which one is the option? Lambda is power 4, 4p square. That means this is the right answer. It's a 9i. So it's a 2p square, it's a 4p square, it's a 4p square, it's a 2p square. So p4, yes, this is the right answer. And it's a minus 2p square, it's a minus 9 iota, but we need a plus 9 iota. So this option is cancelled. C is the right option. The set of the eigenvalues is not equal to the set of this. So what is the property of the eigenvalue? The trace of the matrix and the determinant. What is the trace? 4. Determinant is 3 minus 8 minus 5. So look at the options. Trace will be 4, determinant will be 3 minus 5. So satisfied. 4, 3 minus 5. Trace will be 4, determinant will be minus 5. Trace will be 6. Now you can see that I need a trace 4, but it's a 6. So this is not satisfied and we need a not. So yes, this is the right answer. Rest options are cancelled because rest options have the same property. So the only distinguished property is my D is the right answer. Okay, look at this another one. 2yz is the eigenvector corresponding to the real eigenvalue. Okay, so it has the 3 eigenvalue. Can you find one of the eigenvalue? Firstly, I can see the row sum. What is the row sum is? 2 minus 3, 4. They are not same. Can you check about the column sum? Column sum is 1. It's a 1. It's a minus 2, 1. You can see it's the same eigenvalues. It means one of the eigenvalues my 1. And I need a one of the eigenvalues. So 1 is also the real. So what is the property of the eigenvector? Ax is equal to lambda x. So I can see what is my A? 0, 1, 0, 0, 0, 1, 2 minus 4, 3. What is the axis? Eigenvector. Eigenvector I have 2yz. Lambda is the eigenvalue. It is not given that it's the largest eigenvalue or the smallest. Any real eigenvalue. So 1 is the real eigenvalue. So 2yz. That's over. Now I can equate the coefficient. From the first case, 2z is equal to 2. I got z is my 1. From the second case, 2 minus 4z is equal to y. So I have a z is equal to 1. Find 2 minus 0y minus 4z is equal to y. I have the z is 1. So y will be my minus 2. So what is the value of the z minus y? Z minus y is my 3 is the right answer of this problem. A very simple target for you. Always remember, always check whether the sum of the each row or the columns are same or not. Okay, look at this one. M and N are the two 4 cross 4 matrix which are written like here. Then the maximum value of this. Okay, what is the trace of this Mn matrix? So you can see it will be my basically a 2, 2, 2 and 2. No, it's a matrix, so I can multiply 2 in the each case. Anyhow, can you find the determinant of this? Because it's a diagonal entries. Fine. So it's a 2, 2, 2 and 2. So what is the determinant of the Mn? So 2 multiply 2 multiply 2 multiply 2. So that is a 16. What is the trace? Trace is the sum of the eigens values. Fine. So it means what are the eigenvalues of this Mn? 2, 2, 2 and 2. Fine. Then the maximum value of this determinant of M plus determinant of N. m and n are the two with the integer entries. That's the most important target. Okay, always remember, if the matrix is integer values, fine, then the determinant of m is also integer. Clear? Now what we have obtained is determinant of mn is my 16, and you need a maximum values of this. So what is the maximum integer of this? So clearly say, if one of the this or this is value is my 1, fine. If one of the value is my 1 and the product of it is 16 and other will be 16, that could be the only maximum value you have provided. So what is the answer of this? 1 plus 16. So 17 is the right answer. This is the most crucial thing. If it is given as a real eigenvalues or real entries, then the determinant can be in the fraction, fine. But if you have the real integer entries, then your determinant is also integer. So once it is an integer, what could be the maximum values of this? Okay, so you can easily solve this. Otherwise, there is one more method. If you don't remember these shortcut tricks, so what is the meaning of that? You have to maximize z. If I call this is my x and this is my y, fine, such that the determinant of mn is my 16. So you can solve it by using the, I can substitute this value, this is basically xy is my 16, fine. So z is equal to x plus y, or y I can substitute here is 16 over x. Now you can solve this problem and you can get your answer as a x. But there is no need, as I told you the shortcut trick. M is a 3 cross 3 matrix, so it has a 3 eigenvalues. Alpha, beta are the eigenvalues of this, and the product of them. It means the determinant of M will be my -4, and your target is to find the trace of the M. Alpha, beta, gamma is the trace. Look at that, it's a 3 cross 3, fine. I can obtain the 2 eigenvalues from here. So what is that? Lambda square minus lambda minus 2 is equal to 0. So can you factorize them? Minus of 2 plus lambda minus 2, 0. So what is the meaning of that? Lambda is equal to 2 and lambda is equal to -1. So you got 2 eigenvalues from here. Can you find the third eigenvalue? By using this property. The product of the eigenvalue is my -4. So what is the other eigenvalue? It should be 2 also. So what is the meaning of that? What is the alpha, beta, gamma? And what is the trace of this? 4 minus 1 is my trace of this. And you can see how many lines I have written. I have written only the 3 to 4 lines. So remember, you have to needed a 10 to 15 second time period you solve the problem, and that much time period you are needed to like and comment on the video as well. You need a 15 second to comment, like and subscribe my channel. Okay, look at this another one. M is a real 6 cross 6 matrix. So it has a 6 eigenvalue. 2 and -1 are my 2 eigenvalues. And m raised to power 5 is ai plus bm. Where a and b are real, then which of the following are true? Okay, can you find the 4 other eigenvalues? You can solve this equation, you can get it, but the options are not asking you find the other eigenvalues. So if 2 and -1 are the eigenvalues of my m, what does it mean? It satisfied this equation, fine. So I can satisfy it. So firstly I can simply take -1. So -5, this is my a plus b of -1. So what does it mean? -1 is a minus b. So look at that, a minus b is not equal to -1, a minus b again not equal to -1, a minus b is not equal to -1, a minus b is equal to +1, and the only left option is a. So that's the right answer. Otherwise, if you are unable to make a decision, then you can write as a second equation also, that is my 32, which is a plus 2b. You can solve these two equations. Okay, again you will get as a is 10, b is 11. but make sure there is no need of this because I got the options from these equations. Okay, look at this another one. M is my n cross n 0 matrix, m square is my 0. Do you remember which matrix is here whose square will be 0? This is nilpotent matrix. Fine. So what is the eigenvalue of the nilpotent matrix? Always remember, eigenvalues of the nilpotent matrix are always 0. Since it has a degree 2, so m has a 0, 0 eigenvalue. So if m has a 0, 0 eigenvalue, what is the eigenvalue of the m plus alpha I? M has a 0, alpha I has a alpha eigenvalue. What is the eigenvalue of the m minus alpha I? So minus alpha. Alpha is the eigenvalue of this and this. That's the wrong option because it has a minus alpha eigenvalue. Alpha is the eigenvalue of this. What is the eigenvalue of this? Alpha. It also has a alpha. Minus alpha is the eigenvalue of this. That's the wrong option because m has a 0 eigenvalue. So this has a plus alpha, but he said a minus alpha. Minus alpha is the eigenvalue of this. That's the wrong option because it has a plus alpha. So this option is also cancelled. B is my right answer. Okay, look at this another one. You have to find the determinant of 8i minus m. Now you can see it's a matrix. Your approach will be finding the eigenvalues. Although they are not asking you what is the relationship between the eigenvalues and the determinant, product of the eigenvalue. You can see this is my 0. I can partition these eigenvalues. Fine. So I can find the eigenvalues of this matrix separately. 9, 2, 0, 7. So clearly say this is the diagonal matrix. So 9 and 7 are my eigenvalues. Look at this matrix. It is not a, so I can use this lambda square minus trace and plus determinant. So 0 plus 30. So can you find the eigenvalues of this? It comes to be 6 and 5. So it is my 5 and 6. Clear? Then what is the remaining is you have to find the 8i minus m. This is the eigenvalues of the m. Fine. So what is the eigenvalues of this? It's a minus 1, 8 minus 7 plus 1, 8 minus 5, 3, 6, 8 minus is 2. Because you all knows what is the eigenvalues of the 8i. Eigenvalues of the 8i is 8, 8, 8 and 8. Then you need the cube. What is the eigenvalue of the 8m minus cube? So I can cube them. Minus 1, 1, 27 and 8. Then your target is to find the determinant. So what is the determinant of this? This is the product of the eigenvalues. So I can multiply them. It's a minus 8, 7, 56, 5, 8 to 16, minus 2, 1, 6 is the right answer of this problem. You can see a very simple approach. Whenever you will see the matrix, always find the eigenvalue. Okay, look at this another one. N is my greater than equal to 1. So as any integer, I can choose n is my 2. Then a raised to power k is my I2. Then all the eigenvalues of the a are the kth root of unity. So I can choose k is my 2 also. Any number which is greater than or equal to 1. So what is the I2 is? Fine. So what is the eigenvalues of this? Eigenvalues of the identity matrix is 1, 1. And what is the kth root of kth unity of this? So k is my 2. So it means what is the eigenvalues of this? 1 and 1. So yes, if whenever a k, because eigenvalues of this is 1 and 1, I can return this one is 1 over 2, 1 over 2. So first option is correct. So this option is cancelled. This option is cancelled. Second option said if for some k greater than 1, I can again choose k is my 2. All the eigenvalues of the a are the kth root of unity. All the eigenvalues of the a are kth. Okay, that is the converse of the previous one. So many examples are there. If I simply choose instead of the I can choose minus I. Fine. What is the eigenvalues of this? -1, -1. Fine. All the eigenvalues of the A are the kth root of unity. Instead of this, if I called any number, say 10, 5, anything. So clearly say A raised to power. If you find the A square of this, is it equal to I? No, because of this 10. So it means this option is wrong option. So second is my false, first option is, so B is the right answer. You can see that this has the eigenvalue -1 and 1. Fine. So clearly say this is the right option. Or you can simply take this is my +1, this is my +1. So eigenvalues are my +1 and +1. So which is the kth root of unity. But if you calculate the A square, K is my square, it is not equal to I. N is greater than 2 is the integer. I can choose N is my 2. Always consider the particular value so that it will be easy. So this value will be my Z1, Z2. This is my N is my 2. So this is Z2. The last number is 2 minus 1 is Z1. Where Z is belongs to the linear transformation of this. So that's very simple. What is the basis? You can always consider the basis. 1, 0. Z2 will be 0, 1. So I can write the matrix corresponding to Z2. 0, 1, 1, 0. This is my matrix A. Then A is the nilpotent. So what is the eigenvalues of this? How you can find the eigenvalue? Lambda square minus trace plus determinant. So determinant will be my -1. Fine. So what is the eigenvalues of this is? Plus minus 1. So none of the eigenvalues my 0. So A has not a nilpotent matrix. All the eigenvalues of the A are modulus 1. Yes, this is the correct option. Every eigenvalue of the A are either 0 or 1, but it is +1 as well as -1 also. So but it's not a -1. A is my singular. What is the meaning of the singular is? Determinant of A is not 0, but clearly say what is the determinant of A is a -1, which is non-zero. So this option is cancelled. Only left option is B is my right answer of the problem. Okay, the largest eigenvalues of this A. So it has a 3 eigenvalues. Again we can check about the sum of the columns and the row. So it's a 7. It is my 0. It is my 5. They are not same. If you look about the row wise, it is my 1, 4. It is a 4. It is a 4. It's the same value. So one eigenvalue is my 4. Fine. Now, how you can find the other values? You can see that 2 row has the same values. What does it means? If the 2 row has the same value, what does it means? Determinant of A is my 0. Fine. If it is a 0, what does it means? One eigenvalue is my 0. So can you find the third eigenvalue? I can use the trace of this property. Fine. So what is the trace of this matrix? 2 minus 1 minus 1. That's a 0. So what is the trace of this? Only when it is a -4, then only it's a 0. So what is the largest eigenvalue? 4 is the largest answer of this problem. You can see it's a very, very simple approach. Okay, consider the 2 cross 2 matrix, the 8th power of m, and here. So in this case, m is my 1, 1, 1, 0. I think that's a very simple. You can find its m square. 1, 1, 1, 1, 1, 0. It will be 1 plus 1, 2, 1. It will be 1 and it will be 1. Clear? So then m4. How you can find the m4? I can multiply m square into m square. 2, 1, 1. So it will be 4. No, firstly what is the m8? It could be like of this and this. Okay, if I multiply this by 1, 0, it is my x, y, and your target is to find the value of x. It means if I call this is my A, this is my B, then this is my right answer. Fine, because if you multiply them, this A is my x. So okay, fine. So what is that? 4 plus 1, 5. 2 plus 1, 3. 2 plus 1, 3. 2, 1 plus 1, 2. And the last is M8. So I need to find only 5, 3, 2, 3. So 5, 3, 3, 2. So what is that? It's a 25. 25 plus 9, 34. The first number is my 34. Whatever the other numbers, because it's a M8, so the right answer is 34 is the correct answer. Okay, P is my 3 cross 3 with the 3 eigenvalues are here. V1, V2 are the eigenvectors. Okay, they are my distinct eigenvalues. Fine. If they are distinct eigenvalue, then the entry in the first row and the third column, A13, I need this value. Okay. Which things come in your mind when you have the distinct eigenvalues? That is called as the diagonalization. Fine. So what is that? If you have the matrix P, then I can return this matrix here. What is the H is? H is the matrix corresponding to the eigenvector. So these are my eigenvectors. So 1, 0, 0, 1, 1, 0, 1, 0, 1. What is the D? Is the diagonal matrix with the eigenvalue 0, 1, minus 1. Rest values are my 0. Fine. Now I can substitute them. I can solve it. But instead of the solving, find a H inverse and then D, it could be easy. If I post multiply by H, then it will be my D of H inverse. Sorry, post multiply by H. So H inverse will be cancelled out. So it is my H into D. So now it could be easy for me. I can multiply this by D. So it is a 0, 0, 0, 0, 1, 0, minus 1, 0. This is my HD. So what is that? First value will be my 0. I need a third value only. Okay. So 0, minus 1. Second value will be my 1. Whatever the others are there, because we need only this. What is the P into H? If P is my A11, A12, if I multiply this by H, fine. What is that? First column, first value, A11, first column, whatever the second number, A11 plus A13, and whatever are there. Now you can equate them. What is the A11 will be my 0, and from here A11 plus A13 will be my minus 1. So this number is my 0. So what is the right answer of this? Minus 1 is the correct answer of this problem. Okay. Again, it's a matrix. So whenever you have the matrix, always think about the eigen's value. It has a 4. So you have the 4 eigenvalues. And how you can find the determinant? You can find the product of the eigenvalues. Now look at that. This M, can I return this M? I can break this 10 plus 1. This is 10 plus 1. So this value I can return as 10, 10, 10. Fine. This plus, what is the remaining is 1, 0, 0, 0, 0, 1, 0, 0 here. Fine. So this matrix M I can break, say A plus I. This is my identity. Now what are the eigenvalues of this? Eigenvalues of this are 1, 1, 1 and 1. Fine. Now clearly say, what is the eigenvalue of this? Each row has the sum same. What is the sum is? 40. So one eigenvalue is my 40. Fine. And you can see that trace is again a 40. So the rest of the eigenvalues are my 0. Although you can see the 3 row has the same value. So it means the 3 zeros are there. So what is the eigenvalues of the M? I can add them. This is the eigenvalues of the A plus, because of this plus sign. So what is the eigenvalue of this? 41, 1, 1 and 1. So what is the product of the eigenvalues? Can you find the product of this? 41 is the right answer. Fine. There is no need to solve. You can expand this matrix by usual here. Always apply the concept of eigenvalue. Okay, look at this one. Which of the following is not the eigenvalues of the B? So for that you need the eigenvalues of the A. So A has the 3 eigenvalues. Okay, so you clearly say one of the eigenvalues is my 0. Fine, because the determinant is my 0. Can you find the sum? 0, 0, it's not a 0. Column wise, -1, +1, it is not here. So once you get one eigenvalue as a 0, and the trace will be my 3. So the sum of these two values will be 3. Clear? Now, again a very simple, I can break this into here because of this 0. Always remember, you can break this whenever, whatever you have the breaking line, that breaking line consists of the full 0. Fine. So what is the eigenvalue? This has the eigenvalue only one number, so one eigenvalue is my 2. Fine. And how you can find the eigenvalues of this? Lambda square minus sum and the determinant. So clearly say this has 0 and 1. Fine. Otherwise there is no need to solve like this way. Once we got 0 and 2 are the eigenvalue, the third eigenvalue you can use as the trace. What is the trace of the A? This is my 3. So what is the eigenvalues of this? Fine. So these are the eigenvalues of my A. So can you find the eigenvalues of the B? So when A is equal to 0, what is the eigenvalue of A? 0 raised to power 5, 0 raised to power 4, 0, 0, and this is a 1. What is when it is a 2? It's a 32 plus 16 plus 1. It is my 49. When it is a 1, it's a 1 plus 1 plus 1, 3. So these 3 are my eigens values. So 2 is not be there. So is the right answer. 1 is present because they are asking not the eigen value. Okay. The maximum number of the linearly independent eigenvector. The maximum number of the linearly eigenvector is always the geometric multiplicity of the eigens values. So it is a 4 cross 4. Okay. So you have a 4 eigens values. So firstly we can check whether the row sum is same. It's a 2, 4, it is not the same. Column wise 3, 3, 4, 3, it is not the same. So we can't find that. Now can you partition them? You can see I can partition from here. So you can see it's a simple because this partition has a 0 and this 0. So corresponding to this, what is the eigenvalue? Lambda square, trace will be 3, determinant will be 0. So can you find the eigenvalues of here? 0 and 3. Fine. Similarly for this case, it will be it is upper triangular matrix, so eigenvalues are 3 and 3, but you can find like this plus 9. So what is the factor is? Lambda minus 3 and lambda minus 3. So it will be 3 and 3. Fine. So what is the maximum of is this? Geometric multiplicity of the 0 plus geometric multiplicity of the eigenvalues 3. Now since what is the algebraic multiplicity of the 0? It is a 1, which is same as geometric multiplicity of 0 because it's a unique number. So this answer is my 1. What is the algebraic multiplicity of the 3? Is my 3 because it appears 3 times. How you can find the geometric multiplicity of the 3? That's a very, very simple. That means you have to find the kernel of the matrix. Kernel of A minus 3i. So how you can find the kernel? I can find the rank of this matrix and then by using the rank nullity theorem. What is the rank of A minus 3i? So I can subtract A minus 3i. It's a minus of 2. It's a plus 1, 0, 0. 2 is a minus 1, 0, 0. 0, 0, 0, 0. It's a 0, 0, 1, 0. Fine. Now what is the rank of this? It's a 4 cross 4. So clearly say one value is my 0. So rank can never be 4. Now if you add them, if you add this value, so this value will be again my 0. Fine. So what is that? So what is the meaning of that? Rank of this matrix is my 2. Fine. So once this matrix has a rank 2, what is the kernel of this? So what is the column is? 4 minus 2 by using rank nullity theorem. Rank plus nullity is the dimension. So kernel is my 2. and the kernel is my geometric multiplicity. So right answer of what is the geometric multiplicity of the 0 is 1 plus geometric multiplicity of the 3 is my 2. So 1 plus 3, 2 is 3 is the right answer of this problem. So this is the way you can solve this eigenvalue problem in a very simple manner. We will see the next lecture on the linear transformation. I hope you can like, share and comment on my video. Best of luck students. Happy learning.